We have an integral where the upper limit of integration is infinite, so we are going to express this as the limit as b approaches infinity of the integral from 0 to b of 1 over 1 plus x squared dx. So this will be the limit as b approaches infinity. I recognize this integrand as the derivative of inverse tangent of x, so this is going to be tan inverse of x evaluated from 0 to b. Now as we look at that, we're going to have the limit as b approaches infinity then of the tangent inverse of b minus inverse tangent of 0. So let's think about this for a minute, and actually maybe we'll look at this part first. So this is basically asking us where is the tangent 0, and we know that is at 0. So this part is 0. Now this one, where is the tangent? Where does the tangent approach infinity? And I kind of think of the tangent graph when I do that like this, and I know that it approaches infinity at pi over 2. The other way you could think of it is think of the graph of inverse tangent, and we know there is a horizontal asymptote there at pi over 2. So the answer to this is pi over 2. Now what if we had one that had limits of integration of infinity and also negative infinity? So on both of these. Now as we look at this, this is the same integrand as the last problem. So we could actually do a smart thing if we realize that, because this is an even function and this is a symmetric interval of integration. And so we could actually take the answer we got from the last problem and double it, because this would equal 2 times the integral from 0 to infinity of 1 over 1 plus x squared dx. And that will be true if we have an even integrand here and we have this symmetric interval of integration, symmetric about 0. So we just found the answer to the last one, and that was pi over 2, so we could double that and this would be pi. Now what this is telling us is if we looked at the graph here, this looks something like this. And so even though we're going towards infinity and negative infinity, this area under the curve has a finite value as we approach infinity, and that finite value is pi.